when I was in college, I was in a math class, and the professor shared with us an article that a science magazine had put together, and they had gathered a whole bunch of really smart people, and they had them vote on the top 10 greatest discoveries of all time. Things like, oh, certain medicines, truths about physics, um, formulas, all sorts of things. And in the end, they decided that the greatest discovery of all time was the Pythagorean theorem. Which, when he told me that, I thought, oh, that's kind of weird, right? There are things greater than the Pythagorean theorem in my mind. Calculus is way cooler than the Pythagorean theorem. And then he explained, or the article explained, that up until the Pythagorean theorem was figured out, math was pretty much only used to count things like sheep. I have 3 sheep, you have 4 sheep, together we have 7. I have 3 sheep, I get a little hungry, excuse me, now I have 2 sheep, right? If 4 families each have 3 kids, 4 times 3 is 12 kids, right? So when the Pythagorean theorem was discovered, people started to say, there's something else going on here. And not only did they study the Pythagorean theorem and find out a bunch of really cool things about it, but they started looking at other situations. And so their argument in this article was that the Pythagorean theorem is what convinced mankind and womankind to look into theoretical mathematics. They started looking into things different than just arithmetic. So, the Pythagorean theorem is a squared plus b squared equals c squared. What does that mean? What does the Pythagorean theorem mean? Well, you guys know how to use it, right? What does it apply to? Triangles. Any triangle? Right triangles. So I'm going to draw a right triangle. Okay. And what are A, B, and C? They are side lengths. Does it matter where I put the side lengths? Yes. How do we label the sides? There's one really important thing when we label the sides. C has to be the hypotenuse. Um, hypotenuse is a Greek word, and Greek doesn't translate very well into English, but I'll do my best. So, how do we translate hypotenuse into English? The best I can come up with is it is an occupied toilet on an airplane. Lots of blank stares. An occupied toilet on an airplane. Somebody will figure it out. Doesn't have to be an airplane. It could be a mountain. Nothing. High pot in use. No. All right. Maybe someday I'll be funny. So the A and the B are interchangeable. The two sides that are not the hypotenuse are called legs. And I could put A here and B here, or I could switch those. So the legs are the sides that touch the right angle, and the hypotenuse is the side that doesn't, the longest side. So what does this formula actually mean? Well, in this triangle, is A plus B equal to C? Is side A plus side B equal to C? No, that's not the formula. But is it true? No. Why not? Well, let's put some numbers in there. let's say I had 6 plus 4 equals 10. Can I make a triangle where one side is 6, one side is 4, and one side is 10? Well, let's try it. So here's a 10, and here's a 6, and here's a 4. Can I make a triangle? No, why not? What's wrong with that? Why does it not work? It doesn't connect because what? So how can I, what's that? Right, the 6 and the 4 added together are the same length as the 10. So if I gave you sticks, one was a 10 and one was a 6 and one was a 4, the only way to get the 6 and the 4 to touch is to lay them flat, and they would be the same length as the 10, and that's not a triangle. So A plus B never equals C in any triangle. In fact, A plus B has to be bigger than C. Otherwise, you don't have a triangle. So we know that A plus B must be bigger than C. So if this was like 4.5, or 4, I guess, could I make a triangle that was 4.4, 6, and 10? Yeah, it would be a really skinny triangle. But I could bend that 6 down to here, and then I could bend that 4.4 down, and I get this really slender triangle. Okay. Have you ever wondered, poor people on the video, I got a frog in my throat. Why do we say that is x squared? A square has 4 equal sides. So why is x to the second referred to as x squared? Any idea? So if you had length x, and then I multiplied it by another x, right? This is x times x. It's going to be the area of a square. So if I build a square with x on each side, the area of this is x squared. Well, that's kind of cool. So, with that in mind, what does this mean? What is a squared? Well, it's the area of what? A squared is going to be the area of, anybody have an idea? I love silence. What is a squared in this instance? I'm making you guys nervous. What does it mean? Somebody take a shot. I can edit this silence out of the video. That's the cool part. Welcome. We're enjoying a very long silence in class today. So what does a squared mean? Any idea? No? Did I not do a very good explanation of it? What'd you say? Oh my goodness, that was easy. It's the area of a square whose side length is A. So, if I draw this square here, its area is A squared. So B squared must be the area of a square whose side length is B. And C squared must be an area of a square whose side length is C. Okay? Now, let's throw some numbers in there just for fun. So let's put a 3 here, and a 4 here, and a 5 here. Okay? How do we explain the Pythagorean theorem using areas? Well, 3 squared is 9, which means A has 9 squares whose side lengths are 1 by 1. And B squared is going to have 16 squares. Now, they're all supposed to be the same size, but I'm not a good artist. And C is going to have 25 squares. And notice the 9 squares from over here and the 16 squares from over here added together are equal to the 25 squares over there. So Pythagoras didn't invent or discover the theorem. It existed. It was known before he came around. But he started figuring out stuff like this, and he used it a lot, and that's why we've given the formula his name. Hello? What's up? Oh, okay. So the neat thing is, this is true when the numbers are really friendly, right? This one's obvious that 9 squares plus 16 squares, if they're all the same size, is equal to 25 squares of the same size. But what if the numbers are not nice? So what if I had a side length of 8.6 and let's say 4.3, and then I had C, and I calculated whatever C was. The areas are still going to match. So this area plus this area is equal to that area every single time, even when the numbers are not friendly. In fact, most of the time the numbers are not friendly. So in this case, how would I find C? Well, I can just use the formula A squared plus B squared equals C squared. So 4.3 squared plus 8.6 squared is equal to C squared. Excuse me. So 4.3 squared plus 8.6 squared, I get 92.45 equals C squared. How do I calculate C? Take the square root. So we'll raise that to the 0.5. 9.61. That is the distance of C. Okay, sometimes this assignment is going to want the answer in exact form. So if we had a 5 and a 9 and a C, so that's going to be 5 squared is 25 plus 9 squared is 81 equals C squared. So that is 106. We take the square root. C equals the square root of 106. 106 is 2 and 53, and 53 is prime. So that one does not go any farther. So the answer is 106. If we're missing one of the legs, then the problem is a little bit different. So if I have, no, let's not do that. Let's do 13 and 5. What side am I missing? A or B? A or B? Doesn't matter. So A squared plus B squared is going to be 25. And C squared, 13 times 13 is 169. How do I solve this one? I got to get that 25 to the other side, so we subtract 25. And we get A squared equals 144. And if I take the square root, A is going to be 12. Okay? Now, in some of the problems, you're going to have, it'll be word problems, or there is one I want to show you that's a little bit tricky. Let's see if I've got it pulled up already. The one that talks about 3 dimensions. This one. Okay. These are a little bit tricky. Okay. So I need to know how big is A and how big is B. Now, these A and B are not the A and B from the Pythagorean theorem. These are just variables. Okay. So we know a couple things about this pyramid. We know the base of the pyramid is 5, and the distance from the middle to the end of the pyramid is 5, which means all of the sides of the pyramid are the same length. They're all 10. Okay? We know that the pyramid has a height of 12, and we want to know how big is A and how big is B. So, I'm going to focus on this triangle right here. Okay? And I'm going to grab it and pull it to the side. What do I know about that triangle? Do I know any lengths? 12 is the, it's A or B, right? It's one of the legs. So this side is 12. And I know that the other leg is a 5. And then this is called A, but it's not the A from the A squared plus B squared equals C squared. It was just the name that they gave to that side. So for now, I'm going to call it X. So 12 squared plus 5 squared equals X squared. That's 144 plus 25, which is 169. The square root of 169 is 13. Okay. So now, in this triangle, the distance from the top of the pyramid down the face is 13. Now, we can solve for B. So now I'm going to draw this triangle. I'm going to pull it to the side. Where is my right angle? It's right here. I know that the bottom is 5, and I know that the left side is 13. And now I need to find this, which is the hypotenuse. So 5 squared plus 13 squared equals X squared. 25 plus 169. That's going to be 194. Then we square root. Goes into 194. 2 and 87. 3 and 20. 3 and 29. And 29 is prime. Oh, it probably wants the decimal, right? Yeah. Nearest tenth. All right. I did put it on there. I'm going to open up an assignment called 4.2 assignment or 4.2 worksheet. It's not in there yet, but I'll kick it over to you guys right now.